Hello, and welcome to the webinar, Predicting Energy's High Impact Technologies Before They Scale. My name is Chris Robinson. I'm a Senior Director here at Lux, and I'll be moderating and presenting today's session, along with my colleague, Mukunda Kaushik, an Associate Research Director here at Lux. Throughout this webinar, you can type any questions you have in the questions box in your screen. So time permitting, we'll get to all the questions we can. And of course, if your question does not get answered, please don't hesitate to email it to questions@luxresearchinc.com, and we'll make sure to send a response your way. And lastly, if at any point you experience technical difficulties, such as a frozen screen, simply refresh your browser and check that you have a strong internet connection. So with that, we can jump into the discussion. And the topic at hand today is predicting energy's high impact technologies before they scale. And I often think of this as a really fundamental use case of anyone that engages with Lux, right? We all want to understand what are the technologies that our organization needs to focus on in the next 1 year, 5 years, 10 years. And because many of you listening to this presumably are interested in making sure your organization is prepared for these changes, right? You want to be the one sitting in the room 1, 5, 10 years from now, et cetera, knowing that you understood these technology trends and were able to advise your organization to make the right decisions. But that's becoming increasingly difficult. There's so much uncertainty, right? That's really been caused by changes in policy, volatility in demand and supply of oil and gas products, which we'll talk about in a bit more detail. But amidst this uncertainty, I thought maybe we could start with one bit of certainty. That is, what are some of the decisions that we were making in the past, and where did we find some of that certainty?
Yeah, so you have to make a lot of choices today between seemingly competitive technologies, but this is also not the first time innovation teams have had to make such choices. So let's go back to 2005, where people in a room had to make a decision between photovoltaics and CSP. Right? So it probably didn't feel like a simple technology bet back then. It would have felt a lot more like choosing two very different futures for scaling renewable energy. If I was in a room like that, I'd probably pick PV. It's a bit more expensive, but it's also modular and distributed, and I believe that the benefits of a manufacturing-based cost curve will really have a compounded impact on cost in the long term.
Now, there also might have been folks in the room that were advocating for CSP, folks like myself, noting some of the components are familiar, things like steam turbines for power generation. And I would have expressed skepticism, saying, hey, there are major cost reductions needed that might not be possible. Now, here there was a clear winner, right? We know that photovoltaics and the story that Mukunda just told us did come true. We can also think about other types of decisions. Maybe imagine being an automaker, 2010, right? Again, choosing between two different very futures. I might have picked battery electric vehicles. Maybe I've learned my lesson. Modular cost reductions are possible, and the cost curves of lithium ion will allow cost competitive battery electric vehicles to be in the hands of consumers.
And I might have made a stronger case for fuel cell vehicles, right? Because consumers are never going to be on board with a car that has range limitations. Fuel cells are inherently just more similar to gasoline, and consumers will just prefer that. So again, this was perhaps a bit of an obvious example as well. So let's take a slightly more challenging scenario. Going to 2015, if you were an oil and gas company looking to grow your business in low carbon steel, there's a lot of different options here, but the two main options to consider are CCUS and hydrogen DRI. I would probably bet on CCUS, right? Steel companies have invested in assets and blast furnaces, and decommissioning is expensive, and we can't really afford to drive up the prices of steel too much with expensive hydrogen.
And again, there might be someone in that room in 2015 that might have advocated for hydrogen, right? I would have said, hey, our cost models say this can be cheaper at scale. We can start with existing sources of hydrogen and move toward lower carbon blends over time. Now, a decision like this, I would argue there's really not a clear winner right now, right? I think this is still an open discussion as to which is really the path forward for low carbon steel. And again, we can think of other challenging scenarios, right? In 2020, maybe you decided it was time to bet on a low carbon fuel pilot. Right? I would have advocated for e-fuels, saying we see costs associated with low carbon electricity starting to fall. There's a lot of interest in the hydrogen economy from other industries, and I think the time is right to bet on e-fuels.
I would probably pick gasification, right? We've already cracked the code on gasification for coal. It's only a matter of time before industry successfully adapts it for biomass. Now, of course, Chris and I are simplifying rather complex arguments, but that really is the conclusion in most of these cases today, which means it's hard to make one. And as if there weren't enough variables, we picked today's agenda before the conflict erupted in the Middle East and before Venezuela as well. And all of these incidents have shocked the energy system. So we'll start today by just taking stock of where we are today, specifically in the context of innovation cycles and trends. Then we'll take a look at the Lux Tech Signal as a tool that really tells us what technology innovation is looking like in 2026 and moving forward, and using that as a foresight tool. And then ending that with translating foresight into making it actionable, and end with some takeaways and conclusions. So as we look back at the last 25 years, every decade has had a defining technology where companies made a bet, built projects, and wrote a success story and essentially moved on to the next business opportunity. In the 2000s, that was solar and wind. In the 2010s, that was electric vehicles. The 2020s, for the longest time, did look like it would be the decade for heavy industry, where we really where we transform manufacturing with scaled up decarbonization. And there was also a period where policies were really supporting that trend. But 4 years away from 2030, that doesn't seem to be the case. A lot of the solutions and technologies that we bet on for the 2020s, right, direct air capture, water electrolysis, as well as their derivatives and applications like SAF, low carbon cement, and steel, are at a junction. Innovation interest is not necessarily collapsing, and you'll see that in a bit, but equity investments and project development is starting to take a hit when you compare it to 2022 levels. But regardless of the direction, you need to prepare for what's ahead, right? Because you can't really afford to do nothing in your roles. And if these technologies and their commercial prospects do rebound, it's important that you're in a good spot to regain that momentum. But if they do collapse, it's also important to identify what's next. And in a time when it gets hard to justify your bets, what do the next 10, 20, 30 years of the energy sector really look like?
So it begs the question, exactly what era within energy innovation are we in today, if not heavy industry? And I would argue the answer to that is we're in the era of uncertainty. And I know I'm cheating a bit here, right? We talked about technology themes for the first eras, but I genuinely believe if we sit here in 2030 and talk about really what were the defining impactful themes of the 2020s, we've seen already 3 major supply and demand disruptions to the oil and gas industry. Here in the US, at least, we've seen 2 major policy shifts, both toward and away from low carbon technologies. And I think it's safe to say there'll be a third before the end of the decade. And I think that's ultimately what we're going to reflect on is what was most impactful is the fact that we're in an era of uncertainty. And as anyone focused on innovation within organizations, that makes your job incredibly difficult. This is a study that was published last year, an analysis of firms that both claimed they do innovation well and ones that decided they weren't going to focus on innovation and ultimately faced some of the similar barriers. The first one here, lack of appropriate financing, is something that's always existed and will always continue to exist. How do you secure financial backing for things that might have longer term impacts in the organization? But it's really the second one that's changed significantly in the last just 12 months alone, the economic risks, right? The as you look toward the future, making bets is becoming less and less certain. If you want to invest in large capital projects, there's just so much uncertainty that it's preventing you from doing that. At the same time, I think there's a good case to be made that this could be considered the era of opportunity. If we look back at some of the major changes in the past, the dot-com example, the dot-com bubble, I should say, is a good example. A company like Verizon coming out of the dot-com bubble made an investment in WorldCom, which ultimately laid the groundwork for their 4G networks, an acquisition they made for pennies on the dollar. So if you have the right foresight and the right understanding of technology trends and market opportunities, I think now is actually the time that you can find low-cost bets to make that are really transformative within the organization. So we need to find some of those bets. And here at Lux, we use our tech signal as a tool to predict innovation trends. So to give a bit more detail there, our tech signal is a data tool that we've developed to really quantify innovation interest in a given technology. So what we're doing is pulling in a database of all patent filings, academic paper publications, funding from academic groups or funding from governments, as well as a few other data sets. And we've looked at the adoption of a few thousand different technologies historically to weight and quantify the impact of those on innovation. And so, what we're looking for is a couple of different things. One is, are there technologies which have historically scored very low on innovation interest that are starting to show a rise, indicating that these are technologies that you should be focused on in the future? Or similarly, are there technologies that have showed a sustained high tech signal that indicates something is moving from lab to pilot scale and might be ready to deploy? And if we look historically at the tech signal, it does show us as a pretty good predictor of adoption of some technologies. So if we look at that first era we mentioned, the era of solar and wind, we know today that solar and wind are the two largest sources of capacity addition on the grid today. And if, again, we look at trends in the tech signal, right around the early 2000s, when these technologies started entering the market, we saw a rapid acceleration of tech signals related in these technologies, showing a heightened innovation interest. They also showed something else interesting, which is as technologies mature, they can show signs of falling innovation interest. If we think about kind of the early 2010s, this is when it became quite clear that crystalline PV was going to be the dominant winner, and that manufacturing scale up in China was going to be really hard to compete with. So we saw a drop in things like startup activity around photovoltaics as that technology matured. We also can see the tech signal trend being evident in vehicle electrification. So today, about 1 in 5 vehicles globally produced has a plug of some kind. But again, looking at tech signal data, right around kind of that 2010 timeframe when we saw vehicles like from Tesla or Nissan enter the market, is when we saw that rapid acceleration of the tech signal. And what's interesting about electric vehicles has been the sustained high innovation interest. Within lithium-ion batteries, we've seen a lot of changes in terms of the cathode materials, anode materials used, a focus on additives to enable faster charging. So it's very much been an active area of innovation interest over time. And now we are also seeing the supporting charging infrastructure accelerate. So as we see more vehicles on the road and this technology is starting to mature, some of the supporting infrastructure is showing a lot more acceleration in innovation interest.
So if we take a look at the hundreds of technologies that Lux covers, this is currently the leaderboard for the top 10 tech of 2025, with the highest innovation interest based on the tech signal. And a lot of it should still look familiar, right? So low carbon ammonia, so underpinned by green hydrogen and green ammonia, and direct air capture are still the top 2. And then we also see complementing technologies like CO2 sequestration in the top 10 as well. There's a lot of energy storage, so sodium ion, solid state, flow batteries, as well as a continued push for circularity-driven technology and better end of life. Right? So you see battery recycling and bioplastics as well. But if we take a look at which technologies showed the biggest jump in the last year, so comparing the 2025 tech signal relative to the 2024 tech signal score, there's 3 clusters of topics that emerge. The first, pretty unsurprisingly, is AI. So LLMs and multimodal AI models show a big jump. And we see this increasing, especially as chatbots and digital workers perform end-to-end tasks, and companies actually find a way to use these tools to reduce time and costs by integrating them into real workflows. The second, interestingly, is a cluster of technologies that all have membranes at their core. Right? So alkaline membranes for water electrolysis, membranes for carbon capture, as well as a focus of material informatics on polymers, which can also feed into membrane markets. There's probably a few different reasons for this, but the biggest and one reason that we continue to see a lot of interest from our clients in membranes is because of the compact size of membranes, which allows a lot of on-site deployment ease with high efficiencies, and companies really want to crack the code on manufacturing. The last is really technologies around material extraction and resourcing. So whether that is PV recycling or critical minerals extraction, which you'll hear about a lot as we go through the presentation today. And we also see this being tied to innovation within subsurface technologies, right? So continue to see interest in CO2 sequestration, and other technologies that pop up are things like methanol to jet as it gets clear. And while these technologies are rising, we also see technologies that are falling, right? So some of these are quite specific, right? So others are cases where there is a clear alternative or a competing technology that's doing a lot better. So, for example, there's no big need to produce ethanol from CO2 electrolysis because companies should really be maximizing the bio-based routes or even looking at maybe the LanzaTech approach if you want to use flue gas or CO2 as a feedstock. We also see a dip in the tech signal when technologies reach a certain level of maturity where innovation is not exactly what's needed for the next phase, right? So we see R&D capital transforming into scaling capital. So that's why you see technologies like heat pump, wind, components for lithium-ion batteries, or even liquefaction, for example. So these are trends in what's going up and what's going down, but how do you actually use tech signal data to really adapt and stay resilient to real world conditions? Sticking with the theme of uncertainty today, right, we see three scenarios based on what the data is telling us that we have high chances of experiencing if we're not already. And let's see how we can really use the tech signal to be a tool to identify what technologies are relevant in these scenarios. The data is basically pointing towards three scenarios, right? So a deglobalized transition where countries are basically fending for themselves and working with what they have domestically. And everyone really has a pretty different strategy. The second is an electricity constrained transition where access to power or low carbon electrons is getting more challenging with rising demand. And lastly, a gas powered future where natural gas is still very much the backbone of the global energy system. So we'll spend the next 10-15 minutes or so looking at each of these scenarios, what they entail, and the role of technology innovation here. Starting with a deglobalized economy, right? So while trade is still very much happening today, we still see elements of deglobalization. The figure that you see on the right here is the import intensity of production for different industries within an economy, right? So this is basically comparing 2011 to 2019. And any industry that you see to the right of that central line is basically importing less in 2019 compared to what it did in 2011, right? So the dots that you see in the bottom left, so health, postal, publishing, finance, these are things that are very much the backbone of any running economy. They're basically importing less in 2019 compared to what they did in 2010. So as we think about deglobalization, the four key aspects of the scenario are production and output is really non-negotiable, right? So the system has to be able to cater to a diversified feedstock. And you also need to maximize internal availability, so circularity becomes a lot more important. The cost of producing something domestically might be a bit more expensive, but as it starts to become a necessity in the absence of external allies, the green premium starts to transform and look more like a security premium. And also being futuristic, countries will also start looking at new supply frontiers, right? So space, deep sea, and the Arctic. So which technologies are relevant in a scenario like this? So firstly, we see that direct air capture and water electrolysis have consistently high tech signal scores, right? So there is a very high innovation interest. And while 2026 might not be the best time to build a megaton scale hub, it's also not the time to fold your cards and start avoiding these technologies, right? Because technology driven cost reduction is still very much ongoing. And some examples of what we mean by this is innovations in co-production of CO2 and hydrogen from ambient air, for example, where companies like Greenlight have been able to show a lot of capex optimization and more flexible revenue platforms. So if you can co-produce CO2 and hydrogen, and you can only sell the hydrogen to a customer that can afford about $3 per kilogram, you can offset some of the higher costs of production by selling carbon credits from the CO2 that you're capturing from air. Right? So you're able to meet industry halfway. And the early involvement for technologies like this has been from the oil and gas industry as well as the defense sector. Right? So Rheinmetals, for example, working with Greenlight to produce e-fuels for the military in Germany. or the Repsol Foundation supporting parallel carbons TRL6 validation for a technology like this. The tech signal also shows growth in technologies that support new resourcing. So either circularly within the economy or from completely new frontiers. Right? So we look at things like sustaining domestic PV and battery manufacturing in the absence of trade security, tech signal rising for technologies like deep sea mining, which goes hand in hand with the US providing approvals for polymetallic nodule mining pending environmental permits. And we also see R&D partnerships with universities, right? So MIT working with Boeing to explore quantum sensors for advanced rocket propellants that can really increase payload capacity and generate revenue value, right? So these are some examples of technologies that can be interesting in a deglobalized scenario. But the overall message here is that deglobalization and being cut off from your natural allies can prompt countries to fund technologies for survival, even if it's not necessarily cost favorable, right? So we see that with Japan and e-methane, for example, where Japan has been forming partnerships across the world in North America, South America, the Middle East, and Australia to continue to meet its reliance on natural gas. And for the oil and gas industry, you really get a chance to flip the narrative around technologies like data capture and water electrolysis, and hopefully capitalize on manufacturing-based cost reduction, as we saw in the case of solar.
So the second scenario we have here is the electricity constrained scenario. And I think this is very front of mind for anyone, especially in North America and Europe, but really globally. We are starting to see electricity growth decouple from economic factors like GDP growth or population growth. And that is because of things like electric vehicles switching from fossil hydrocarbons to electricity growth. But the biggest challenge today has been, as more industries electrify, the ability to secure an electricity connection has been more and more challenging. So this is a look at here in the United States, the plot on the right here, interconnection queues, and you can see the number of projects sitting in an interconnection queue awaiting for a grid connection has expanded by about tenfold in the last decade. And that is because you have smaller, more distributed projects like solar and wind projects, in addition to new sources, things like data centers, which are really pressuring the grid's ability to respond and provide power. So if the last decade or two is really about how do we make and store low carbon electrons, in the future it's really going to be how do we get more out of the grid in order to meet some of those demands without having to overbuild and accelerate infrastructure build out as we have had historically. And there are a couple of important ways we should think about this. The first of which is how do we tap into latent grid capacity, right? So when we talk about transmission congestion or even distribution network congestion, the typical capacity factor is maybe 30, 40, 50% for a lot of those lines. It's really a peak small number of time per year that those pieces of infrastructure are really stressed. So the question becomes, as a new consumer looking to secure a grid connection, how do you actually tap into those times when there is excess capacity on the grid? And I think that's where we're seeing a lot of interest in things like distributed energy resource management systems or bidirectional charging. Really, that's how we'll bring about flexibility from small scales. We're also seeing a lot of interest from data centers and things like flexible grid connections, right? Where you accept I may need 250 megawatts of power, but if I need to be curtailed, you can curtail me to 150 megawatts as needed. The other way we think about this is securing new rights of way for new infrastructure can be very challenging, particularly in urban environments or in North America and Europe. So how do you get more out of the existing rights of way? And there we do see an acceleration of interest in the last couple of years in things like dynamic line ratings and novel transmission technologies, things like low sag conductors or novel superconducting wires. And what's interesting there is we did see high tech signal values throughout the 2010s. There was a lot of interest and a lot of foresight, understanding that, with the transition toward PV, with the transition toward electrifying a lot of sources like electric vehicles, that these solutions will be needed. It was simply that the challenge really wasn't there. The problem hadn't become large enough. Now we are seeing that problem become large enough, and we are starting to see some of these technologies actually being deployed, and there's some market pull for these technologies. The other thing we'll need to think about as we think about the future is the density of power generation. We already see some regions, as Mukunda noted, he talked about Japan's preference for e-methane. Japan is a good example of a country that cannot electrify solely with solar, wind, and batteries. There is simply not enough land. Other regions like Korea or even parts of Europe, parts of North America could even experience challenges with the density of power generation if you look at specific assets like refineries in some cases. So the question becomes, how do you achieve higher density in low carbon power generation? And the answer is really looking for clean, firm generation. We see a lot of interest in nuclear and geothermal today, but I also wouldn't count out carbon capture solutions. We've had more conversations around carbon capture for power generation in the last year than I can say I've had in the previous 10 years. Really looking at how do we pair carbon capture maybe with natural gas, which has a conventionally low profile, a low concentration profile of CO2. But we are starting to see some companies develop some solutions for direct air capture, now pivot to think about natural gas capture as well. That allows you to keep existing infrastructure of generation and fuel supplies while still keeping carbon emissions low. Now, ultimately, when I look at what's going to be the most important over the next decade, as I mentioned, it's how to tap into the power grid to find unused capacity. And the key word to think about here is flexibility. How do we build a power grid that leverages flexibility of demand? And here there are two things to think about: large loads and small loads. Within large loads, there's a reason we talk so much about data centers. There are customers that are willing to pay a lot for power. There's a very large amount of power demand. Some of these hyperscalers are looking for 200-300 megawatts of power, and they have urgency. They need to move quickly to build these data centers. So I think we'll see flexibility solutions emerge in the future with several layers of flexibility. Some amount of compute flexibility, some amount of spatial flexibility, looking at routing loads between data centers. So if one data center in a congested region, can that look for another data center in a non-congested region to route those loads to, while also maintaining on-site generation and storage to provide flexibility. Within smaller loads, it's really about marketplaces. How do you build the right markets and business models to allow distributed small loads of things like bidirectional EV chargers, at-home storage batteries, to provide flexibility services to the grid, curtailing demand or even injecting power into the grid during those times of high congestion? Both solutions will be needed in the future.
Okay, and the third scenario we'll look at today is really gas as a backbone, right? So it's really all about natural gas. And in this case, we're basically talking about solutions to one, clean gas, so decarbonize natural gas, but not necessarily replace it, right? Then we're also talking about ensuring better movement, so creating hyper-connected gas markets, making sure that liquefaction export terminals are operating at their highest efficiency. We'll also be looking at upgrading natural gas, right? So can you produce new molecules from natural gas that are conventionally produced from oil or CO2 or other types of feedstock, right? As well as a focus on more blue molecules. And of course, intelligent infrastructure. So layering it all together with that digital layer and identifying inefficiencies, methane leaks, and diagnosing before it becomes an issue. And some technologies that are relevant in this case are things that are subsurface and CCS, right? So Chris spoke about how there's been growing interest within natural gas with carbon capture in the context of data centers. And while most oil and gas companies, if not all, are active and familiar with saline aquifers and depleted oil and gas fields, we're also seeing a growing interest in basalt mineralization and onshore solutions. Right, so where the benefit is you turn the CO2 into a solid, essentially, so you only need to monitor it for about a 2 to 5 year timeline, as opposed to several decades. So if you are operating a CCS hub, but that capacity gets booked out and filled up over the course of 10, 20, 30 years, you don't want to be continuously monitoring while you're lacking revenue from new CO2 coming in. And we see initial startup innovation in combining CCS with alternative technologies that also operate in subsurface environments, right? So for example, can you combine CO2 sequestration with geologic hydrogen, whereas the CO2 gets mineralized, it's actually producing hydrogen, right? That's what Decahydron is looking into. Or a company like Factor 2, which is combining CCS with CCS in relatively shallow depths with geothermal power. The other trend that we see is essentially materials for the methane ecosystem, as well as materials that can convert methane into other molecules and platforms, right? So technologies like photocatalysis or dual functioning materials, which are largely academic now, are starting to show initial commercial momentum in producing, let's say, liquids like methanol out of methane while bypassing the syngas intermediate, right? So you have companies in Australia looking at that. And we also see a lot of interest in self-healing materials, and the tech signal is just starting to pick up, right? So the rate is not as high as what you might have seen for direct air capture or solar, but you see that initial uptake. So intelligent materials for self-healing pipelines that can prevent corrosion in pipeline interiors. But overall, the main message with gas as a backbone is that it's not necessarily synonymous with business as usual. We're trying to extract more from less and really make sure that we're improving operational efficiency and also strengthening system integration. And also making sure that we're tapping into methane sources that are also more diversified and maybe a bit more distributed, right? So process intensification for biomethane and RNG, for example. It's definitely established that LNG is a transition fuel, right? So the figure that you see here shows the number of new vessel orders for the marine sector going up to 2030. And even towards the end of the decade, about 70% of new vessels will be powered by LNG. And if these vessels are going to be running for the next 20, 30 years, it shows that gas will still be really important as we move into 2050. But again, it's not business as usual. But the key thing to also consider is that you're not necessarily picking and choosing between these scenarios. A lot of them are actually happening simultaneously. And we see more of that when the system is shocked, right? So, can you pick technologies that help you stay resilient in several of these scenarios? So, for example, the first one was during COVID, right, where countries really realized their dependence on foreign manufacturing with solar batteries and global logistics systems. We saw a lot of refinery shutdowns and tighter fuels and chemicals markets that are still apparent today. Challenges for the aviation sector, as well as CO2 supply shortages from the fertilizer industry, which impacted food and beverage. And this really led to a lot of reshoring or reshoring manufacturing either domestically or within closer allies. It also led to the launch of a lot of new industrial policies, right? So domestic energy, domestic manufacturing, energy manufacturing, and things like that. It also led to a big surge in residential energy demand just because people were home a lot, which caused a rising interest for rooftop solar and on-site storage. The second example is the petrochemicals industry in Europe, which is already a system living in multiple futures. Right, so we see petrochemical plants and refineries offshoring from Europe and moving towards Asia. But at the same time, Europe is also investing very heavily in LNG as it tries to reduce imports from Russia. So, with a lot of strong policy frameworks in place, we see this conflict between security and decarbonization, right? So technologies that can help you stay resilient in multiple of these scenarios are also really interesting. And carbon capture just being a quick example from what we've discussed so far, where it's useful in an electricity constrained environment, but also in a gas as a backbone environment.
So we want to wrap up today, with a little more specific guidance, not just highlighting the technologies you think will be successful in the future, but how do you go about actually taking action across these? And there's more than just understanding technology readiness or predicting technology readiness, like our tech signal can help you do, that goes into making a decision around a first of a kind investment, whether it's developing a new product or developing a new project. Right? Beyond this, we also need to think about product definition. Right. And this might sound obvious, but think about what I mentioned around grids, that flexibility was an important theme. That is a system characteristic. From a product perspective, that would be building virtual power plants, building new types of interconnection agreements that have flexibility integrated within them. Those are products that have buyers and sellers. We also need to think about market organization, right? And there's a couple of different layers to this. There's does the right supporting ecosystem exist in terms of infrastructure, right? If we're talking about anything related to molecules, do we have the trucks, the pipelines, the tankers to actually move these molecules from the area of production to the point of consumption. But there's also the regulatory angle, right? Does the right regulatory environment exist to support this? Or are there any regulatory barriers that would prevent you from moving forward or have risk? You also need market readiness. And really simply, this is, are there buyers out there ready to buy the product that you're selling? What are they willing to pay for it? And I think this is why, in a lot of ways, the 2020s ended up not being the area of heavy industry, that the buyers were not ready, that they didn't believe that their costs were coming down enough. They were concerned about economic risks in the future and ultimately didn't make the changes that they expected to make. And so market readiness is an important factor to consider. And finally, production. There are also two layers to this, right? So part of this is, does the supply chain exist, which could be the right network of component suppliers or even just raw materials for them to make their components. But the other consideration often overlooked is, do you have the right expertise, right? If you're an oil and gas company looking to build a water electrolysis project, do you have the right electrochemical expertise? Do you have the right engineering expertise, maintenance and facilities engineers? These are important things to consider as you look into a first of a kind investment. Now, I also promised you we'd also think about how do we translate these technology trends to the future. And I want to discuss, what does the 2030s look like if we're going from solar PV to EVs, and 2020s is the era of uncertainty. I actually think 2030s might be the era of heavy industry, where we really see industrial decentralization accelerate. Now, the reason for this, I think, is simple. We see falling costs for low carbon solutions. We see accelerating tech signals for alternatives to fossil hydrocarbons. But really crucially, we're also seeing rising volatility, right? And I think that's going to be one of the biggest triggers today, that we've had major supply and demand shocks in the oil and gas industry. We've had major regulatory changes. And I think we will see companies start to think about factoring in, as Mukunda noted, the security premium or the risk premium associated with fossil hydrocarbon startups. So what might this look like? We might see industries making that sacrifice for opting for something that could be higher cost, but comes with more stability, maybe switching from fossil hydrocarbons to biomass as a chemicals producer as your feedstock. We could see more interest in things like direct lithium extraction projects, where maybe the economics of DLE right now is not very promising, but we know governments are putting a heavy emphasis on localized supply chains, and customers of lithium will also be thinking about localized supply chains and reducing foreign exposure. So ultimately, I think the clear message here is that if we look at these 5 factors and think about any project related to decentralization, whether it's building a microgrid to make your power on site, sourcing biomass locally as your feedstock or to make fuel or chemicals, the market readiness is changing. All of this volatility is really priming any customer of oil and gas of any kind to reconsider their alternatives in light of high prices and increasing volatility. So to kind of share some conclusions to wrap up today, one, we are in the era of uncertainty. I think this is going to be when we reflect on the theme of the 2020s. It's going to be that the system experienced significant shocks in supply, demand, and regulatory changes, and increasing frequency of those shocks. And ultimately, that is what's going to catalyze change. You're going to see companies reevaluating decisions, factoring in the risks associated with relying on fossil hydrocarbons into their decision-making in the future. And ultimately, the thing to watch for is this idea of a green premium being replaced as a security premium, where the same technologies that could underpin a decarbonization strategy are adopted, but for different reasons, really focusing on security. So with that, that concludes our presentation today. Thank you, Mukunda, for joining me. We'll now be taking questions that you might have in the presentations, which you can type into the questions box. And as a reminder, if we don't get to your question on this call, someone from Lux will be in touch after the webinar today. So I see one question coming in. Please keep entering those. The first one that came in is around the tech signal. So how often does Lux update the tech signal, and how do you layer in the tech signal to consider other first-of-a-kind considerations?
Yeah, so the tech signal is a dynamic tool within the Lux platform. So if you ever want to see the most recent version of it, always reach out, let us know. But roughly we update it about 6 months or so. But as you saw with the examples here, it's really year over year when you start to see trends and patterns. right? So in terms of how you combine it with the other factors that we just looked at, when you notice external factors within your organization or in your region, right? So whether that's production or market organization, when that changes, it's good to just check the tech signal and see how it's responding, right? So if you don't see offtakes in a market and you see a dying tech signal, that's a strong signal. But if you see poor market conditions but a rising tech signal, as we just saw with data capture, water electrolysis, you're probably just waiting for the right time for market conditions to pick up. Right? But the message here is really that if uncertainty breeds change, innovation has a role in that change. And organizations need to consider that. And the tech signal is a way to really quantify that innovation factor, which can otherwise seem a bit nebulous. I see one other question. So with the current situation in the Middle East, diesel prices are rising very quickly. Have you seen that impact low carbon trucking?
Yeah, I could take this one. I know I've done a lot of our work around kind of trucking here at Lux. So, I think there's kind of two answers here. One is I would say no, not immediately, right? So I don't think anything has happened on a near enough time scale that we've seen any specific changes happen because of this. But I think amongst the industries that we talk about, I think this one is the most prime for change, right? We've seen a significant rise in diesel relative to some of the oil and gas prices we've seen. And really, anyone that's a consumer of diesel, right, especially trucking, we're talking low margin, fuel costs are very significant for them. I do think this could catalyze a shift, either thinking about higher blends of biodiesel for kind of a near term basis, or catalyzing a shift to reconsider electrification. But one of the challenges I think also with trucking is, really how quickly can this shift happen just because there's a really big change needed to happen with CapEx and OpEx, right? You look at the trucking industry, it's so OpEx heavy that you're really asking people to spend a very high cost upfront in a time of uncertainty, right? Where some of those payback periods or payoff is a little bit uncertain. So that's why I think, we called 2030s the area where I think we'll see some change, where I don't think it's going to happen tomorrow, but all of the conflict and volatility we're seeing does kind of set that stage to reconsider decision making. I think we'll see a lot of action happen in the 2030s, especially within trucking. So I think that's probably all the time we have questioned for today. So thank you, Mukunda. That'll conclude our webinar for today. So the slide presentation recording will be sent to all attendees via email later today. So after you leave the webinar, you'll be prompted to complete a survey on today's presentation. We do appreciate any feedback you have. Helps us to inform and improve future webinars. So lastly, take a moment to check out our upcoming webinars on our website. And thank you for joining us, and have a great day.